Dear students, continuation to the average output voltage derivation of a single phase fully controlled rectifier with RL load without freewheeling diode with freewheeling diode. So in this session, we are going to discuss about the derivation on the RMS output voltage for the single phase fully controlled rectifier with RL load with freewheeling diode. So as we understood that by using the freewheeling diode across the RL load, what happens, which prevents the reduction of the DC output voltage. Due to the presence of an inductance, the DC output voltage decreases. To prevent that, we should connect the freewheeling diode across the RL load so that the reduction in the DC output voltage can be controlled. So in this session, we are going to discuss about how to derive the expression of an RMS output voltage with the RL load with the freewheeling diode. So let us see the derivation on the RMS value of the output voltage for the single phase full rectifier with RL load with freewheeling diode. Before that, so once again we should remind the things which we have discussed in the previous class. That is an average output voltage of a single phase fully rectifier with RL load with the freewheeling diode. So thyristor T1 is triggered at omega t is equal to alpha, and its conducts from omega t is equal to alpha to pi, and the average output voltage V naught is equal to Vm sin omega t. It shows that the output follows the input supply when the for the period omega t is equal to alpha to pi, and the freewheeling diode which conducts from omega t is equal to pi to beta. Therefore, V naught is equal to VDC is equal to 1 by pi integration of omega t is equal to 0 to pi V naught d omega t, and V naught is Vm sin omega t into d of omega t, and then integrate that sin omega t with respect to t, you will get minus cos omega t. Then VDC becomes 1 by pi into minus cos omega t into Vm. That is Vm by pi into 1 minus cos omega t, and Vm by pi into omega t is ranging from 0 to pi, right? Then cos alpha minus of minus 1. Then what do you get? You can substitute lower limit and upper limit as alpha and beta. Beta is equal to pi. For the low value of inductance, you will get Vm by pi into 1 plus cos alpha as the average DC output voltage. Look here. So this is the waveform for the single phase full wave conductor rectifier with RL load. By using the freewheeling diode across the RL load, these spikes, what are the spikes here, means appearance of the negative output voltage during the negative off cycle. Okay, that can be prevented. So this can be prevented. So therefore, the reduction in the average output voltage that can be our DC output it can be controlled by using the freewheeling diode. So next we will see how to derive the expression of an RMS the output voltage. So V naught RMS is equal to 2 by 2 pi into integration of alpha to pi plus alpha, and V naught square into d of omega t whole to the power of 1 by 2, that is nothing but square root. Okay, V naught RMS becomes square root of 1 by pi into integration of alpha to pi plus alpha Vm square into sine square omega t, because V naught output follows the input during this period, that is V naught is equal to Vm into sine omega t. So substituting V naught is equal to Vm sine omega t in this equation, we are getting this equation. Next, so look here, take Vm square outside of this integral symbol, so that Vm square by pi integration of alpha to pi plus alpha sine square omega t into d of omega t whole to the power 1 by 2. According to the rules of the trigonometry, so what you can write, sine square omega t can be written as cos 2 omega t, 1 minus cos 2 omega t by 2. Substituting, replace sine square omega t by 1 minus cos 2 omega t by 2, we'll get V naught RMS is equal to Vm square by pi into integration of alpha to pi plus alpha into 1 minus cos 2 omega t by 2 into d of omega t whole to the power 1 by 2. And split this integration, you will get Vm into, if square root of Vm square is Vm, and into 1 by 2 pi. You can take 2 outside that. Then you will get Vm into 1 by 2 pi integration of alpha to pi plus alpha into d of omega t minus integration of alpha to pi plus alpha cos to omega t d omega t all to the power 1 by 2. So integration of this d omega t is omega t. This omega t is ranging from that is that pi plus alpha to pi plus alpha. Substitute over there. So what you will get? You will get this equation, that is V naught RMS is equal to Vm at 1 by 2 pi plus alpha minus sine of 2 pi plus alpha minus sine 2 alpha by 2 1 to the power 1 by 2, and then you get Vm into 1 by 2 pi. This alpha minus alpha get cancelled, phi is left out here, and this sine 2 of phi plus alpha. Use the trigonometric rule, sine of a plus b is equal to sine a cos b plus cos a sine b. So in the same way, we can write sine 2 of phi plus alpha can be written as sine 2 pi cos 2 alpha plus cos 2 pi sine 2 alpha minus this sine 2 alpha as it is, divided by 2 whole to the power of 1 by 2. So now, so this equation which is simplified as Vm into 1 by 2 pi into pi minus sine 2 pi is 0. Understood? Then the sine 2 alpha, sine 2 cos 2 pi is 1. So you get sine 2 alpha minus sine 2 alpha. Sine 2 alpha minus sine 2 alpha is 0. This entire time is 0. Pi get cancelled. Vm by 2 is left out. Vm by root 2 is left out. So Vm by root 2 is the RMS value of the output voltage for the single phase fully rectifier with the what is that RL load using the freewheeling diode. Okay, freewheeling diode. So that is also this is also very important for examination point of view. So I need here to study both the average value of the DC output voltage for the single phase full rectifier with RL load with freewheeling diode, and also RMS value of the output voltage for the single phase fully conductor rectifier with the RL load and using the what is that freewheeling diode. Okay, so this is once again very important for examination point of view. Okay, thank you for watching this video, and next I'll move on to the